Welcome back. Today we'll be focusing on the next part of our chapter. That means, we have studied about what factorials are, what factorial function is, and now let us jump or dive into arrangements. It depends on each situation, basically. I would say, because some situations need an orderly arrangement. Things have to be written in order, but in some arrangements order doesn't matter. Order doesn't matter. So how to know whether it matters or doesn't matter and all? I know you might be thinking about that, and if you're not thinking, then I am thinking about that. So anyway, that we'll all come to see. And look at this situation, which all of you probably would have seen, the pin code. So to enter pin code, we know that we need to have a proper pattern. We make a pattern and we need to have a proper order. For example, if the numbers are 1 2 3 4, if your pin is 1 2 3 4, I have to enter it in the same order. If I jumble it up, if I write 3 2 1 4, it will show incorrect password, right? So the order is pretty important. Now let's go for another example. Your keyboard, there's a definite order in which the alphabets are kept. QWERTY, this order of keyboard is called QWERTY. Why? Because it has the first letters are the first six letters are QWERTY, QWERTY. So this type is called QWERTY keyboard. So there's a reason why this is kept like that. The arrangement is kept like this, and you cannot change it. I mean, of course there are other formats, but usually the very common one of keyboard pattern is QWERTY. So there is an order. Again, there's an order. Now another example. So whenever you open WhatsApp, you see that you need to verify your number. And if I type a mobile number, if I change few digits, for example, if this is my uncle's account number, sorry, uncle's phone number, and if I just say, oh, if I just interchange 1 and 5, if I put them, oh, there are 3 5s together, oh, it doesn't look good, let me interchange them. If I put 1 instead of 5 and put this 5 here, it will go to someone else, right? So, or if I say, oh, +1, I don't like +1, I'll write +3, it will go to someone else. So order is pretty important. And so this is some 11th class of some school. Okay, this is not your class, it's some school. So there are few people like this, and so here also the order is pretty important. Why? Because there is a roll number. Because of the roll number, you cannot shift the people. You need to write the people's name in the same order. For example, in your exam, if you write your name and if you write some other roll number, there will be a confusion, and sometimes the exam paper might not even be evaluated. You might not even get it corrected. So the roll number is pretty important. So it has to be in order. Again and again, I use the same word. There are some cases in which you can arrange names, you can arrange letters, you can arrange numbers, but everything has to be in a specific order, or the order is very important. Okay, now these type of things are called permutation. I know it is a very difficult, it's a big word, I know, but just please try to understand it for now. Permutation is permutation, this type of arrangement, the arrangements where order is pretty important, order is very important, is called permutations. Now let us take our pin code, for example, our pin lock. How many ways are there to write a pin code? Do you know? So I have, these are the numbers that I have: 1 2 3 4 5 6 7 8 9 0. I have to use it within this all these 9 numbers, sorry, 10 numbers. And how many ways are there to make a pin code? So the first digit, the first digit here, there are 10 ways. So I can say there are 10 ways, right? It can be 0, it can be 1, it can be 2 3 4 5 6 7 8 9. There are 10 numbers, so there are 10 options, there are 10 possibilities. Okay, then the second digit, there are how many possibilities? See, second number also there are 10 possibilities, right? Because it could be any number between 0 1 2 3 4 5 6 7 8 9. So 10 possibilities. Third digit, again 10 possibilities. Fourth digit, again 10 possibilities. So what is the total possibility of how many 4-digit numbers can you make? How many? No, actually not 4-digit numbers. How many 4-digit pin code can you make? That is, how many pin codes can you make with this 10 numbers? It will be 10 into 10 into 10 into 10, because each has 10 possibilities. Each digit has 10 possibilities. So the total possibility is 10 into 10 into 10 into 10, and that is 10,000, or I can write it as 10 to the power 4. It's a better way of representing 10 to the power 4. Now keep listening to me very carefully. I can write this as n to the power k. And so what I'm doing is, I am going to call the number of elements. These are the number of things that we have, number of things with which we can play with. Then this thing is called the sample space. The things that we have, this is the space, these are the things which we can do anything, and the number of elements that we have, and the number of elements are called n, and the options that we have, the spaces that we have here in the options, it is called k. K or r, usually you can use k or r. In this PPT I'm using the letter k, so I can write this as n to the power k. n elements with k options. You have only 4 options here, so k options. n elements, k options, n to the power k. Now I was very fine with it, but then suddenly Mithun messaged me saying, "Sir, I do not want to repeat any digits." That means before a pin code could be 1111 also, or 1122. But in that case, there's a repeat. 1 is repeating, 2 is repeating. But Mithun messaged me saying that he doesn't want to repeat in digits, and I asked him why. And then he told me, it makes the password very weak. And I was like, okay. So then I thought, I should honor him, and therefore I thought, I will respect his opinion, and I will do that. So what happened? Now I need to make a pin code with no repeating digits, no repeating numbers. So how to do that? So let me take the first digit. This is the first digit. So the first digit, I have 10 options again, as usual. 1 2 3 4 5 6 7 8 9 0. I have 10 options. Perfect. The second digit, so suppose I took 8. Okay, suppose I took 8, so I'm cancelling out 8. Suppose the first digit is 8. Now the second digit, I have again 10 options, but minus 1. Why? Because you see, I cannot repeat the number again. That means, suppose it was this number, I can repeat it. So how many options do I have? 1 2 3 4 5 6 7 8 9. 10 minus 1. So the first digit I had 10 possibilities. The second digit I have only 9 possibilities. Now suppose I took 6, so I cancel that also. Now how many possibilities do I have for the third digit? 10 minus 1 minus 1. That is 8. So for third digit I have only 8 possibilities. 1 2 3 4 5 7 9 0. Suppose for third digit I took 4. Now for the last digit, for the fourth digit, How many possibilities do I have? 1, 2, 3, 5, 7, 9, 0. 7. I only have 7 possibilities. That is 10 into 9 into 8 into 7. The total possibilities of making a pin code with four numbers are 10 into 9 into 8 into 7, and that the answer of that, you can always find it out. That's all yours. But now let me show you something else, very important thing. Suppose there are 10, we only looked for 4 spaces, right? 4 options. Suppose there are 10 options and I have 10 numbers. So how will the possibilities be? It will, without repeating, if I don't want any digits to repeat, it will be like this: 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? Because first digit will have 10 digits, 10 options, then second digit will have 10 minus 1, 9, third digit will have 10 minus 2, 8, 10 minus 3, 10 minus 4, 10 minus 5, so it keeps going. So last digit, 10th digit will only have one option because the last number which no one took. So look at this number carefully, my friends. 10, 9, 8, 7, 6, 5. What is this? This is 10 factorial. Right. So I think now you understand why we studied about factorial functions. Anyways, remember this. With this understanding, we need to go back to our previous problem. So coming back, 10 into 9 into 8, 7, I can write it as 10 factorial. It is part of 10 factorial, it is part of 10 factorial, but the rest of the numbers are not there. So I need to cancel them. How to cancel them? I will divide it by 6 factorial. Because the rest of the numbers, when I divide by 6 factorial, it will go. So 10 factorial divided by 6 factorial, I get this. Now this number 6, it is not a magic number, that I just put, oh okay, let me just put the number 6. No, it didn't come like that. There's a reason why the number 6 came, and that is, okay, this is the answer, by the way. 10 factorial by 6 factorial, 5043, if you want to know. So there are 5000, so there is 5040 possibilities, of finding your right password. So if I take your phone and if I have no idea what the password is, there are 5040 chances, 1 in 5040 chances will be that I find the right password, by the way. Okay, anyways, now there's a reason why this 6 came, and how it is 6 is 10 minus 4. So I know that 6 is 10 minus 4. That is not what I'm trying to tell. I'm telling you, the reason why I'm telling you, there's a reason why the 6 came. What is 10? 10 is the number of elements that you have, the total number of elements. And what is 4? Number of options, the number of choices, or the number the how much you can pick out. You can only make a 4-digit number, or you can only make a 4 number pin code. So that is your constraint, or that is your options. You only have 4 options, but you have 10 elements. So this 10 factorial by 6 factorial is actually 10 factorial by 10 minus 4 factorial. And this is why the 6 came. The 6 is actually came because of these two numbers. Now if I generalize it, I can write this. I told you, number of elements are called n and the number of options are called k. So I can write it as n factorial divided by n minus k factorial. Right, this will be the general format. Now my friends, this is the formula for permutation: n factorial divided by n minus k factorial, where there is no repetition. See, where there is no repetition, if repetition is fine, if repeating is okay, then it is just n to the power k. Very simple. But if repeating is not allowed, then this formula comes: n factorial divided by n minus k factorial. because we keep using it. It keeps coming, it keeps coming up in many things. So that is why we have another way to represent it, and that is NPK. So NPK means P stands for permutation. N is the number of elements, K is total number of elements, K is the number of options. So NPK is actually n factorial by n minus k factorial. Now this, I hope this much is understood. So let us go and study an example for now. Look at an example. So here I'll try to show you few examples on permutation. Now I have already okay, I have not taught you combinations yet, so you won't be able to understand that. Leave it. Okay, so let me show you one example. But again, let me tell you one thing that before I start doing anything, that is, see, the main thing is understand the theory well, because if you understand the theory well, you'll be actually able to use it. Because if you just study the formula by heart, NPK formula or NPR, whichever letter you use, so you can say, okay, NPR is equal to, or NPK is equal to n factorial divided by n minus k factorial. That is not enough. You should know how it works. That is how it actually that's what makes the understanding clear. Okay, that's enough introduction. So let me start. Suppose I'm giving you 5 numbers: 1 2 3 4 7 and 8. Suppose I'm giving you 6 numbers. Leave 5 numbers: 1 2 3 4 7 8. 6 numbers I have given you, and I'm going to ask you something. How many ways are there to make a 3-digit number? Out of these 6 numbers, how many ways are there to make a 3-digit number, provided that no digit repeats itself? It should be unique. No repeating digits. How many ways are there? So we all know we can directly use the NPK formula, that is n, the total number of elements, 6, pk, 3-digit, the options are 3, so 6p3, and we can say it is 6 factorial divided by 6 minus 3 factorial, that is 3 factorial. You can solve it and find the answer. That means it will be 6 into 5 into 4 into 3 factorial divided by 3 factorial. 3 factorial gets cancelled. Answer is 6 into 5 into 4. This is the answer. Now this is by applying the formula. But even without applying the formula, we can find it. That is this is just for your understanding that I'm telling you. That is 6 numbers are there. So how many options are there for this digit? 6 digits. It could be any of the 6 numbers. So 6 options. Okay. How many options are there for next? If suppose I had taken this number. Suppose I took this number off. That means one digit is taken off. One number is taken off. How many options are there now? How many choices are there? 5 possibilities. Now how many possibilities are there? 2 digits are taken off. How many possibilities? 4 possibilities. So the number of possibilities are 6 into 5 into 4. Same what we get to the formula. Yeah. Now one thing that I want to tell you guys is how do you know whether it is multiplication or division or addition or subtraction? What do you need to do? So I can tell you one thing to make you understand that. You could have said, sir, why can't it be 6 plus 5 plus 4? Now why it is not 6 plus 5 plus 4 and why it is 6 into 5 into 4 is because this 3-digit number appears as one unit. For example, it is not some, for example, if the 3-digit number is 154, it is not some 154 somewhere. No, it is not. It is 154. It is one single number. It's a 3-digit but one single number, 154. It is not some 3 digits put somewhere together. No. So that is why it has to be multiplied. The number of possibilities has to be multiplied. Now you can understand that in terms of an example, that is, take a 2-digit number. This is just for you understanding, okay? How many ways are there to make a 2-digit number? We know that, there are okay, so how many ways are there to make a 2-digit number? Now if you ask me, there are two other. So with the numbers that we normally use are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. First up, let me tell you a little of a history here. These numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, these numbers are called as Indo-Arabic numerals, because it is actually made by Indians. It was, made by Indians in very, very early. That means the very earlier ages. That is around 500 AD, many centuries back. So, but then it was popularized by the Arabs. That means the Arabs took it to the Western countries, and so that is why when the Westerners looked, it looked like the Arabs brought it, but actually the Arabs came and learned it from India. So this is called as Indo-Arabic numerals. Anyway, that's just a history. So how many ways are there to make a 2-digit number? Now let us see. So there are 10 numbers, 4, 5, 6, 7, 8, 9, 10. So there are 10 possibilities, and since one digit is already taken, there are 9 possibilities. So the answer is 10 into 9, right? Nope, it is not. Now why I say it is not? Because you cannot put the number 0 here. Why? Because 0 is, suppose the number is 0, 1. Is it a 2-digit number? No, it is just 1. It is a 1-digit number. Suppose the number is 0, 5. Is it a 2-digit number? No, it is just 5, 1-digit number. So the first digit cannot be 0 if you want it to be a 2-digit number. So we need to rearrange whatever we studied, whatever we did till now. So what will be the answer? Here we cannot have 0, and so rest of the numbers we can have anything. So it will be how many possibilities? So there are 9 possibilities, so 9 options. Then here how many we can have? Here no, there is no problem in there is no problem in not having 0. I mean, we can always have 0. So wait, where's my pen? Yeah, so we can always have 0. So there are 10 possibilities, but one digit is already taken. Suppose it is this, so there are only 9 possibilities. So 9 into 9. So what is the answer? 9 possibilities into 9 possibilities, it becomes 9 into 9, 81. Now I was trying to show you why addition, why we didn't do 9 plus 9, but we did 9 into 9. Now you can prove this by it will take some time, but it is worth but if you really want to know, it is worth it. That is, what is the smallest 2-digit number? Smallest 2-digit number is 10, and the largest 2-digit number is 99. Start counting from 10 to 99 and see how many numbers are there. You will see that there are 81 numbers. This is the proof that I can give you. Or you can just subtract 99 minus 99 minus 10, and then so it will be 89, and sorry, you can't, there's no possibility, there's no use of subtracting 99 minus 10. Anyways, so you just keep counting So anyways, you just keep counting. I would say just keep counting, and you will see that there are only 81 possibilities. By the way, I would like to add one thing, that is, this 81 possibilities is in the case where we took that the numbers are not repeating. That is, we took 9 into 9. If the numbers are repeating, it becomes 9 into 10. That means 44, 54, sorry, 55, 66. In this case, the numbers are repeating. These cases we have not taken, right? Because we took the possibilities where the numbers are not repeating. That is why we got 81. But if you want to know, if you want to get the 2-digit numbers exactly, how many 2-digit numbers are there, even in the case of repeating numbers, then you have to take 9 into 10, because you don't care whether the number used or not. The 10 options, you use the whole number 10, and then you get 90. 9 to 10, 90. So there are 90 possibilities of finding 90. There are 90 possibilities of 2-digit numbers if the numbers are repeating, and there are only 81 possibilities of 2-digit numbers if the numbers are not repeating. Okay, so keep counting and know the answer by yourself. Thank you.